close to definition of temperature, average kinetic energy of molecules of any substance. So heat is average kinetic energy of molecule of each substance represent of heat. Heat you show by Q. Unit of heat is joules or calorie. So unit of heat is joules or calorie. How do you convert calorie times 4.18 convert to joules. Calorie times 4.18 convert to joules. Calorie times 4.18 convert to joules, or joules divided 4.18 convert to calorie. And this is a scalar. You measure the heat by calorimeter, but temperature is when we compare amount of heat of two environment, two different environment or two different objects. So you want to compare amount of heat of the two different objects. So you want to compare amount of heat of first environment with second environment. First object with second object is temperature. You measure the temperature by thermometer, and thermometer. So thermometer we have a three different scale to measure the temperature. You have a three different scale to measure the temperature. First, you measure the temperature in terms of centigrade or Celsius. Any temperature has a two different points. First is lowest constant, at which point temperature for melting ice 0 degree, and second highest point, for example, or second point is constant, is change of gas from water. And you divide it between 2 points. Here is 100, and you divide it by 100. 100 part. You divide it between 2 points by 100. This is temperature in terms of Celsius or centigrade. Celsius or centigrade. Second format, a scale to measure the temperature in terms of Fahrenheit. So, at 32 degrees of Fahrenheit, ice convert to melting, and at 212 of Fahrenheit, water can convert to gas. Here, you divide it between 2 points is 118 part. And next one, here is in terms of Fahrenheit. in most of lab, you measure the temperature because this is 2 minutes. You divide it 2 minutes hard and more accurate use in different lab for this one. Set format is a scale to measure the temperature for Kelvin, in terms of Kelvin. You show by K or capital T by K. Lowest temperature is 273, highest temperature 733. At 273, ice convert to water, and 373, water convert to gas. And here again you divide it between 100 part. Here 100 part. So you have a 3 scale to measure the temperature, centigrade or Celsius, Fahrenheit and Kelvin. We have two formulas. Temperature in terms of Kelvin is centigrade plus 273, and temperature in Fahrenheit is 1.8 times C plus 32. So if you have a temperature in terms of centigrade or Celsius, you can find the temperature in terms of Kelvin, centigrade in terms of Fahrenheit. You can formula to calculate the heat. First formula. So, first formula to measure the heat. Q equal. Q, I told you, Q, amount of heat has a direct proportional relationship with mass of your substance, any element. Amount of heat has a direct proportional relationship, C. C is a specific heat capacity. What is C? Pay attention to sentence. In your assignment, you can do one of them. C, a specific heat capacity. What is it? What is unit of mass? Or kilogram. You suppose you have a 1 gram iron, 1 kilogram iron, 1 gram gold, 1 gram water. So, for example, temperature of water is 12. You give the heat to increase the temperature to 13. 12 to 13. How many degree increase? 1 degree. Amount of heat. You give the mass of your substance compound to increase 1 degree. To increase 1 degree temperature is a specific heat capacity. A specific heat capacity is amount of heat. You give the mass of compound, gram or kilograms, to increase 1 degree. 52 to 53, 68 to 69 degree, increase 1 degree temperature in terms of Celsius or Kelvin is C. C is a specific.
Just 1 degree or two?
Only one. Heat capacity. Is amount of heat needs to increase 1 degree temperature of mass of, unit of mass of any substance is a specific heat capacity. So, but amount of heat has a direct proportional relationship amount of mass. A specific heat capacity has a direct proportional relationship. C, a specific heat capacity. And last one, amount of heat has a direct proportional relationship, amount of change of temperature. Final temperature minus initial temperature. And so, first formula for heat, only increase or decrease the temperature. A state of material doesn't change. A state is solid, liquid, or gas. Doesn't change. Only increase the temperature. Q equal mc delta T. Q equal mc delta T. Q equal mc delta T. Q equal m. Amount of heat has a direct relationship with mass of your substance, a specific heat capacity, change of temperature. M. C, change of temperature is final temperature minus initial temperature. Final minus initial. So, for example, a specific heat capacity of water, is 4,180 joules per kilogram times centigrade. What is meaning? If you have a 1 kilogram water, you need to increase 1 degree temperature, 15 to 16, 28 to 29. How much heat you need? 4,180 joules energy you need. So a specific heat capacity of ice is 2,090 joules per kilogram times centigrade. So, a specific heat capacity of ice is half of water, always. A specific heat capacity of ice, half of water. What is meaning? If you have a 1 kilogram ice, you want to increase 1 degree temperature, -8 to -7. How much heat you need to increase temperature? 2,090 joules energy you need. So, M represents of mass, here unit of mass, gram or kilograms. C, a specific heat capacity. A specific heat here, unit of a specific heat capacity is joules per kilogram times centigrade or calorie per gram times centigrade. You can write in terms of gram, in terms of kilojoules. So, if unit of a specific heat capacity should be joule per kilogram times centigrade, if unit of a specific heat capacity of any substance, unit should be joule per kilogram times centigrade, unit of heat is joules. Q equal mc delta T. If unit of a specific heat capacity of your any substance should be calorie per gram times Celsius or centigrade, unit of heat should be calorie. So Q equal mc delta T. Another definition here, so here is C is a specific heat capacity. C represents a specific heat capacity. But we have another definition, heat capacity. Doesn't have a specific. Heat capacity is multiplication mass times C. Multiplication mass times, this is mass. C is a specific heat capacity. So, you show, for example, C prime. So, Here, unit of mass, joules. Unit of mass, kilograms. Unit of this one is joules per kilogram times centigrade. So here, kilogram cancel. Unit of this one, joule per centigrade should be, for example. So, first formula for heat, Q equal mc delta T. M represent of mass, C a specific heat capacity. This is change of temperature. How much temperature rise? How much temperature change? Final temperature minus initial temperature. Mostly has to be in terms of Kelvin or centigrade. So unit of heat, joules, kilojoules, calorie, kilocalorie. But mostly is joules. And as I told you, how do you convert calorie times 4.18 convert to joules. Unit of heat or energy. Unit of heat or energy. Calorie or joules. 0 degree. You want to convert to water. So, if you give the heat, Arsham, you have an ice 0 degree. Ice as a solid. Yes? You want to give the heat. So, if you give the heat, what happens? Arsham, what happened? Water, which temperature of water? How much temperature of water? Yes, convert to water can be. Which temperature of water? 0 degree. You give the energy to broken the bond. Here, ice 0 degree to water 0 degree. So you give the energy to broken the bond. Temperature doesn't change. Temperature doesn't change. Temperature doesn't change. So here, temperature doesn't change. Temperature doesn't change. So, you give the energy to broken the bond. Here, ice 0 degree, here, converts solid to liquid. Here, the name of heat is LF. L subscript F is LF is latent heat fusion. Latent heat fusion. Latent heat fusion. So this is such as you mentioned hidden fee. You see, if you calculate something, you pay payments. Mention hidden fee. This is heat inside the substance. When you give only broken the bond, temperature doesn't change. So unit of this one is joules per kilograms or calorie per grams. This is for 1 kilogram ice. 1 gram ice. If you have in this room, you have a 5,000 kilogram ice. You have to times by mass. Here is QF is MLF. QF equal MLF. So this is for 1 kilograms ice, iron, gold, nickel, silver. This is for N kilogram. M represent of mass, unit of mass. Kilograms or grams. QF is formula for heat. QF. So you give this amount of formula heat to convert solid to liquid. Solid to liquid. QF equal MLF. QF equal MLF. So this is a specific amount of heat. Temperature doesn't change, only change solid to liquid. So unit of heat always joules or calorie. Next case, if you have for example, water 100 Celsius or centigrade, if you give the heat, what happens? Water convert to gas. Gas 100 degree. Temperature doesn't change. Temperature doesn't change. Here, a state of material change from liquid to gas. Liquid to gas. Liquid to gas. Liquid to gas. Temperature doesn't change. Temperature doesn't change. So, you show LV, latent heat, vaporization. So here you have a 1 kilogram water 100 degree or 1 gram water 100 degree, you give the heat. So if instead of 1 kilogram you have a 6 kilogram water, you times by mass should be how much? QV. This is heat. Unit of heat is joules or calorie. Unit of mass is kilogram or grams. So, this is second formula. You need to heat, you give them any substance, change solid to liquid, solid to liquid. QF equal MLF, QF equal MLF. Next formula to change liquid to gas, QV equal MLV, MLV. So, in two cases, temperature doesn't change. Temperature doesn't change. So LF is latent heat fusion, LV latent heat vaporization. So this is change solid to liquid, liquid to gas. This is for unit of mass, unit of mass. For 1 gram or 1 kilogram, when you times by M, this is amount of heat for n kilogram, 5 kilogram, 1000 kilogram, 200,000 kilogram, QF, QV. So until now you learn three formula. First formula only change the temperature. Q equal MC delta T. Q equal MC delta T. Second formula, when you change solid to liquid, third formula, to change liquid to gas. Temperature doesn't change. You give the energy to broken the bond between molecule of water, between molecule of any substance. On the container, you have, for example, water. You have a coffee. You're adding the milk. You're adding sugar. You're adding something else. You mix. You make the mix or mixture. In this case, any material, any substance has a higher temperature, lose the heat. Any substance has a lower temperature, gain the heat. After lose and gain, finally all of them reach to one temperature, constant temperature. The name of this temperature is final temperature. So if you have a mix, some material, after gain or lose the heat, all of them, if any substance has a higher temperature, lose the heat. Any substance has a lower temperature, gain the heat. Finally, all of them reach to a specific temperature. Same temperature. The name is final temperature of mixture. So, you show by TF. So, you can say, based on one of the thermodynamic rules, you can say Q1 plus Q2, any material you have, has to be equal to 0. If you give the heat should be positive. If you lost the heat, should be negative. Here is positive, here is negative. So, here, if you mix some material, should be M1. C1 T1 plus M2 C2 T2 as much as can you have over M1 C1 plus M2 C2 and some material. TF is final temperature. Final temperature. Final temperature mixture. So this is top M1 C1 T1, two material, 5 substance, doesn't know, M1 C1 plus M2 C2 and rest of the this one.
زده میشه بعد تمپرچر
نه زده نمیشه. اونجوری بشه.